Okay. Last time we finished the paper from at question 3.
Okay.
We discussed it. I think, is there any problem in 3? That is, we have to go from W is okay.
Yeah, we did W. We have to do it.
W is okay. Z is okay, I think. And yeah. Enthalpy change of hydration of calcium 2 plus gas. Hydration of calcium 2 plus gas. Yes. So it's Z. In Z, there is one hydration of yeah. Now we already calculated Z. We already calculated Z. We know Z. Inside Z, there are two things. Hydration of calcium 2 things plus 2 into hydration of Cl minus gas. So we already calculated Z, and hydration of chloride is given here, minus 364 into 2, because 2 chloride moles are hydrated. So we know that one also. So very easily you can get hydration enthalpy of calcium ion. Hydration means the enthalpy change occurs when 1 mole of ionic gaseous compound, when 1 mole of ionic gaseous compound, actually ionic gaseous compound, dissolved in excess water to form its aqueous state. To form its aqueous state, it is always exothermic. It is always exothermic. If I ask some extra question, why it is always exothermic? Because the newly formed bonds are stronger than previous bonds. Newly formed bonds are stronger than, why? When the gaseous ion dissolves in water, it forms iron dipole bonds. Iron dipole bonds are the most strongest type of secondary bonds. Before it dissolves, between water molecules, there were hydrogen bonds. Between gaseous molecules, just ionic bonds. So, because the formed bonds, newly formed bonds are stronger than previous bonds, it is always exothermic. That means the temperature of the system increases. So, however, that's the thing. So, yeah, it's always exothermic. Yeah. So you can calculate it by this equation. Just Z minus 2 into hydration of chloride will give you the answer. Hydration of calcium. Okay. I don't go to calculations, numerical calculations. I think It's clear. Method is the important thing. Okay. We know that. For write an expression in terms of W, X, Y, and Z to show how the enthalpy changes of two of the transformations can be used to calculate the lattice energy of calcium. Lattice energy. So, lattice energy is formation of solid. The enthalpy change occurs when 1 mole of solid ionic compound is formed by gaseous ions. Enthalpy change occurs when 1 mole of solid ionic salt is formed from ionic gases or gaseous ions. Okay. Yes, that's right. So, how can we take the lattice energy? So, it's already given. Lattice energy is here to here, no? Here to here, here to here. Calcium 2 plus and C2Cl minus gases form this. This is lattice energy. Delta H naught. Lattice energy of calcium chloride solid is calcium 2 plus gaseous plus 2 Cl minus gaseous forms calcium chloride solid. This is lattice energy. This is lattice energy. So it's equal to Z no. Here we can write Z equals minus W. You know, in these, according to Lavoisier and Laplace law, you can totally take the opposite direction of an arrow by changing the symbol, positive to negative or negative to positive. By changing the symbol, you can totally take the opposite direction equation. So W, if you say minus W, the arrow is to downwards. This W arrow becomes this direction. When you say minus W. So Z equals minus W, X is to the same, plus X plus Y. And lattice should be minus W plus X. Minus W plus X. So minus W plus X is equal to lattice energy. Yeah, equal to lattice energy. That means it is equal to Z minus Y. Z minus Y. So this will be the answer. Okay, it's a good question. State whether the lattice energy of calcium chloride is more or less exothermic than lattice energy of magnesium fluoride. So let's only think about the cation. Cation charge density is higher in Mg2 plus. Why? You know, charge density depends on two things. We always try to go with the cation. If the cation is same, we can go to anion. Otherwise, cation has more power always. Cation. Higher the charge, higher the charge density. If the charge is the same, go to radius or size. Lesser the size, higher the charge density. So both calcium and magnesium 2 plus charge is the same. Magnesium 2 plus is smaller than calcium 2 plus. Because magnesium 2 plus is smaller than calcium 2 plus, it has higher charge density. When the charge density becomes high, lattice energy also is more. Always, all the lattice energies are exothermic because it forms a more stable compound. Gaseous ions form a solid compound. So the newly formed one is more stable. So the bonds are more stable. So it's totally exothermic. So uh, it is more exothermic. Magnesium fluoride formation of or lattice energy of MgF2 magnesium fluoride is more exothermic than calcium fluoride. It is totally because of Mg2 plus ion has more charge density than calcium 2 plus ion. That's the reason. Okay. Sulfates of group 2 elements vary in solubility down. Yeah. Give the names of two solutions that could be mixed to form barium sulfate. Yeah, you can use barium nitrate and sulfuric acid. Or yeah, or barium nitrate and sodium sulfate. Barium nitrate and sodium sulfate. They are just solutions, no, not precipitation. Barium nitrate AQ with sodium sulfate. This will form barium sulfate solid precipitate, which is not dissolved in nitric or any other acid. Okay, and sodium nitrate, NaNO3. Okay. State and explain how the solubilities of the sulfates group 2 vary. Yeah. Solubility decreases downwards the group. Solubility decreases. Okay.
Yeah.
And explanation, downwards the group, cation size increases. So it becomes, they are explain how solubility of sulfate of to vary. Yeah. Solubility decreases because the thing happens is the interaction between ions increase, because when cation size increases, the ionic density decreases. So the ionic nature decreases, and they try to get together with each other. So they try to more precipitate by attracting each other than staying as ions. So it is precipitate. It likes more to precipitate. In another way, the mass of the sulfate is increased. When the mass increases, they like to become precipitate due to the interactions. Okay. Identify the substances liberated at the anode and at the cathode during electrolysis of saturated KCl-AQ. So it's AQ. There is water. When there's halide, no need to think about any other thing. Halide oxidizes at anode. No problem. Halide oxidizes at anode. That's an example. So Cl2 gas. At cathode, K plus is there, H plus is there. And H plus, not H plus, it's O level way. So yeah, when we take potassium and hydrogen, or potassium and water, potassium is more active, hydrogen is less active. So here potassium is not the one first react. It's water. Water takes electrons. Water takes electrons and forms OH minus and hydrogen.
Hydrogen.
OH minus and now normally the O level ways we do as H plus. No? H plus takes electrons and from hydrogen.
Oh wait, we have to show the half equation.
No. Just the production, no?
Yeah.
So H2 yeah. No need to show the reaction. Okay. Next. And when dilute sulfuric acid is electrolyzed, oxygen is at anode. Water oxidizes and oxygen is given out. That's correct. Dilute sulfuric acid is electrolyzed for 15 minutes using current of, okay. Calculate volume of oxygen liberated under room conditions. Okay. So produce Faraday's constant for this. We will do the question. Let's take the reaction. At anode, water Oxidizers give electrons out, forms oxygen. Electrons out and H plus is formed. So OH plus and 4 electrons. Yeah, this is the reaction. And electron means current. And they give us the current flow. You can calculate the current amount from that, Q equals IT, I equals QOT, so Q equals IT. Current is how much? 0.75. Amperes means coulombs per second. Time is 15 minutes. 15 minutes means 15 into 60 seconds. So this gives 15 into 60 into 0.75 coulombs. Coulombs. Like 2.83 coulombs, something like that. No, 675 coulombs. And Faraday constant, these are in your data book. You can use the data book. And in Faraday constant means the charge of 1 mole of electrons. It is how much? 96,500. So moles of electrons is 100 coulombs per mole. So this gives moles of electron. But if in the data booklet they give 96,490 or a different value, we had used that. Here I just assume Faraday constant is 96,500. 0.0069. 69 moles. So then ratio point. If that is the electron moles flow, how much is the oxygen moles flow? In balanced equation, electron to oxygen ratio is 4:1. 4:1. So oxygen moles is 0.0069 divided by 4. 0.0069, 0.007 divided by 4 moles is the moles of oxygen. If you know the moles, you can go to volume. They say everything is measured under room conditions. So at room temperature and pressure, 1 mole of anything is 22,400 cubic. This is also you should take from the data booklet. This is a general assumption, I say. 22.4 cubic decimeters or 22,400 cubic centimeters is the volume of a gas, volume of an ideal gas at room temperature and pressure. So if that is the volume of 1 mole, what is the volume taken by this formed oxygen moles? It will give you the volume of oxygen. Moles equals volume over molar volume. Moles equals volume over molar volume.
So we take the volume and multiply by the moles of O2.
Yeah. Let's take 0.00175. Here it is 0.00175. Then moles equals volume over molar volume. Volume equals moles into molar volume. So oxygen moles is 0.00175 into molar volume is 20. They want in cubic centimeters. 22,400 cubic centimeters per mole. This is it. This will give you the value.
Yeah.
If there's any difference, that difference is because I didn't look at the data book. I just gave you approximate molar volume value and approximate Faraday constant. Otherwise, method and everything is the correct and same. That is the way you have to do this calculation. $39.2 cubic centimeters will be the answer.
Okay.
Halogens, chlorine, bromine, iodine differ in their strength as oxidizing agent. These strengths are indicated by E naught value of these halogens. Give E naught values for chlorine, bromine, iodine. Acting as we have to check from the data booklet. I can say that the E naught value is higher in chlorine is better reducing agent. Chlorine has a higher positive value. I mean, a higher value than bromine, and bromine has higher value than iodine. Higher value means not the numerical value, the positivity. If all are negative, chlorine has less negative. Bromine has the other. Iodine has the highest negative, like that. The positivity of chlorine is the highest, like that. Okay. Reduce which of chlorine, bromine, iodine will react with the solution of SN2 plus. And here also we have to check data booklet, and we have to check whether which one can oxidize SN2 plus to SN4 plus. That means which one has which chlorine, bromine or iodine has a higher electrode potential than SN2 plus tannous. The one with the halogen with higher electrode potential, E naught value, than SN2 plus will oxidize it. Here also we have to go with the data book. Normally we don't keep these values in mind. We only keep in mind that hydrogen has zero. It's the reference. Third one is also the same. We have to check reduction potentials of chlorine and Mn2 plus, and then only we can think whether chlorine can oxidize Mn2 plus to permanganate or not. Here all the questions are depending on the data booklet, electrode potentials. And electrochemical cell can be made by connecting, yeah, calculate standard cell potential. So E naught cell equation is E naught cell equals E naught cathode minus E naught anode. E naught cell equals E naught cathode minus E naught anode. So we have to check the data booklet and ferrous ferrico sulfate tetrathione persulfate. We have to check which one has higher electrode potential. The one with higher electrode potential is cathode. The one with lesser electrode potential is anode. Then you have to use this equation. E naught cell equals E naught cathode minus E naught anode. The one with higher electrode potential is cathode, other one is anode. Describe one change to each half cell that would increase the value of the cell potential. If you increase the concentration, the cell potential will be increased for sure. If you increase the concentration, cell potential increases. Yeah, concentration is a good answer. Here temperature is a constant. Now, if I explain more, Fe2 plus is in equilibrium in this type of cells. Fe2 plus is equilibrium with Fe3 plus electron. So if you increase the concentration of Fe2 plus, you know, according to Le Chatelier's theory, reaction shift to right. It forms more electrons. Then its negativity increases. Electrode potential decreases. Electrode potential decreases. Now go to this equation. If it is cathode, when electrode potential decreases, E naught cell decreases. But if it is anode, if electrode potential decreases, the difference between cathode and anode increases, so E naught cell increases. So here, if you increase Fe2 plus concentration, you can think what happens, but you should know whether ferrous ferric one is anode or cathode. Without knowing that, you can't explain the answer. But if you know that, you can totally discuss, you can totally explain the answer.
Thank you.
Uh, define the term transition element. Having partially filled d orbitals even at one oxidation state. The elements with partially filled d orbitals at least in one oxidation state. They are transition elements. That's why all d block elements are not transition elements, especially scandium and if we take 3D, scandium and zinc are not transition. Complete electronic configuration of isolated gaseous Fe3 plus ion. So we can take first Fe and yeah, Fe is 26. No, 26 means I don't write all. I don't write all, but after 4s2, it is 3d6. From this, 2 electrons should given out. So it will be 3d5. 3d5. That's it. Name 2 charged elements whose isolated gaseous atoms have same number of electrons in the subshell as an isolated gaseous precursor. 2 charged elements. Gaseous atom. They need 5. So 5 in 3D. That means the 7th one. Cobalt. In cobalt, there are 5 electrons in 3D orbitals. And there's another one, chromium. Chromium also has 5 electrons in 3D orbitals. Cobalt 2 sulfate is added to a water to form a pink solution containing complex ion P. Yeah. An excess of concentrated hydrochloric acid is added to this solution. Blue solid tetrachlorocobaltate. Complete the diagram to show the three-dimensional structure of Q. Yeah. Tetrachlorocobaltate. So it's 2 minus. Name is tetrachlorocobaltate 2. It's a negative ion, so it ends with 8 suffix cobaltate. This nomenclature of D block or transition element compounds. Name type of reaction is in P forms Q. In P there are water molecules. Water molecules are substituted by chloride, so it's substitution. Actual nucleophiles, the ligands are nucleophiles, electron-rich group. So if someone say nucleophilic substitution, still it's correct. Transition element compounds are colored because due to the partially filled d orbitals, electrons show d to d transitions. That's the exact point. Due to the because they have partially filled d orbitals, electrons show d to d transitions, so colors are generated. If you want to say more, the d orbitals also have two energies. It's separated into two energy states. So electrons drop from high energy level to lower energy level of d orbitals. So according to the or equal to the energy difference, it gives out waves. It may have color. Colors of P and Q are different because the types of ligands are different. Type of ligand, the oxidation state, the central atom type, everything affects on color. So here the ligand type is different, so color is also different. Solution of bidentate ligand 1,2-diaminoethane. Bidentate means the same ligand supplies 2 electron pairs to the central metal. Bidentate. Yeah, octahedral. Yes, and that cobalt and yeah. Cobalt 2 becomes cobalt 3 here. One is the ligand changes, so substitution. Other one is oxidation of cobalt. Cobalt oxidizes from +2 to +3. So that is the other type of reaction. 3-dimensional. Okay. Okay. So 8.
Okay.
And in other one, this n group should be the plane of two n group should be totally 90 degrees different. Plane should be in a plane, horizontal plane. On the board, it's not easy to draw. The plane should be 90 degrees different. You can check it from the marking scheme. No?
Yeah.
It goes with the other plane. Stereoisomerism is, we can say, what? Mirror image isomerism. And coordination number is 8. Yeah. Coordination number means number of ligands attached to it. It's 8. K-stability of complexes. K-stability is the equilibrium constant. That means same as Kc, which is there for the formation of each complex. Expression for for HGCN. Yeah. So you know this HGCN 4 2 minus is formed by Hg2 plus iron plus 4 cyanide equilibrium. It's like writing Kc, K stability, concentration of Hg CN4 2 minus. Concentration of this divided by Hg2 plus Aq concentration into cyanide concentration 4 power. That's case stability. Totally like me writing Kc. An aqueous solution containing Hg2 plus is added to a solution containing equal concentration of cyanide. Yeah, so the one with highest K stability will form more easily. It is more stable. The one with least K stability will form in least concentration. So tetracyanide mercuric mercurate ion is the highest. This one is the highest, no? First one should show the highest concentration. Third one is the second. HgI4 is the second. First, the highest. Second, the least. The higher the K stability, the higher the concentration, the compound it forms. Can we finish from there?
Yeah.
And we will continue the next time. Okay. Okay. Let's finish.
Okay. Thank you.